I mentioned at the very beginning that for a skill like programming, although we do have to have a handle on conceptual things, know terminology, understand what these features like loops and variables are doing behind the scenes, it didn't make much sense at the very beginning to begin throwing terms at you, to begin talking and defining terms and giving you formal definitions for things. Because if you think about it, if you'd never written any code and I just began talking about variables and types and storage and control flow, that would go over your head pretty easily. But we do have to talk about a couple of conceptual things early on. And over the course, we will flesh out all the stuff that we've already been seeing and using to a great extent. But one thing we have to talk about, because it's extremely important for our next topic, which is called functions, is the lifespan of data. So we already know that a variable, so let's pick a variable here, a variable like this variable sum, clearly has some kind of a lifespan. It begins existing at some point, and its existence ends at some point. And maybe it's clear that it doesn't exist before line 11. We create it on line 11 when we declare the variable. But it turns out that it also ceases to exist at a very well-defined time. And the concept of when variables begin and end their existence is called scope. And it is critically important that we understand this, because we will soon discover that it is absolutely fine for there to be two different variables in the same program, two completely independent variables that both have the same name. And that sounds pretty scary. And that's one of the reasons why talking about things conceptually can sometimes not help us. But we have to talk about this now. So the concept of scope is talking about when I use a specific name, where does the compiler go looking for it? What variable do I retrieve when I use a specific name? So before I talk more about that, let's just run this code quickly. So what this code does, it's a rehash of a previous example. It starts with a value n. It counts from 1 up to 5. For every value of n, it computes the value n squared and then folds that into a sum and then prints out the sum at the end. And it counts to 5, so the sum should be 55. So we'll run that. And there it is, the sum is 55. And we can observe that if we were to draw a diagram of this, and from now on, I'm actually going to call this diagram I keep drawing. I draw a diagram when I trace code. It turns out that the diagrams that I use have a name. Now, the format I use for my diagrams is apparently mine. I don't remember. I sort of made it up over the years. But I always call my diagrams scoping diagrams. And we'll see that that's significant, because it turns out the reason we draw these diagrams, not only to keep our thoughts organized, but because they really help us solve the problem of scope. So when I draw the diagram for this program, I would start on line 9, which is empty, and I draw a box and I label it main. And it turns out that we refer to this box called main as the scope of main. And formally, the contents of main are everything between the beginning of main, the first opening curly bracket, and that closing curly bracket at the end. We might have noticed we've seen other curly brackets in programs, and they always match up. Every opening curly bracket must have a partner closing curly bracket. So at the beginning of main, I'll draw a box on my scoping diagram that says main. And then I reach line number 10, and I create a new variable called n. Its type is int, and its value is 1. And I also create on the following line a variable called sum, and its value is 0, and its type is int. But then I get down here, and I get to this while loop. And I'm not going to continue my trace. I want to sort of ease into this. But notice how on line 15, I declare a variable called n squared. On line 15. Okay, so you'd probably agree, certainly, as of line 23, the variable sum definitely exists, because I created it on line 11, and line 23 is after line 11. On line 18, the variable n definitely exists, because I created n on line 10. And I didn't do anything in the meantime that seems to have destroyed the value n. Okay, so the question in the comment is, if I uncomment this line, why doesn't it work? And we'll just take a look at what the compiler has to say. It says error on line 22, when I try to print out the value of my variable n squared, which I definitely declared on line 15. On line 22, it says error. The variable n squared is undeclared. It's undeclared. And to be clear, if I were to comment out another variable that I use, I would get the same error. Notice how here, the first time I ever try and use my variable sum, which is now on line 16, it says sum is undeclared. You never declared the variable. Okay, that's all well and good. Of course it said sum was undeclared because I commented out the declaration. Let's go back to what I had a minute ago. In fact, let's clear this so we don't get too confused. It says the variable n squared is undeclared. But I didn't comment out the declaration. It's right here. So what happened? Well, clearly, there was a variable called n squared because I used it. I definitely used it on line 16 and nothing bad happened. But when I try and use it on line 22, it's gone. The compiler thinks it never existed. So what happened? And I'll give you the punchline in advance. As of line 22, for some reason, n squared, the variable, has ceased to exist. And that's why we need to talk about this. We need to understand when is the end point of a variable's lifespan. And it actually has to do with curly brackets. It turns out that line 19, this closing curly bracket, is where the variable n squared ceased to exist. We have to maybe model that a bit more comprehensively than just saying, oh yeah, think about the curly brackets. We have to understand how to trace this code. So let's change examples and maybe ramp back up to this question. Okay, so here's a file called scope1.c. And in this file, I am creating three variables, a, b, and c, 5, 10, and 100. And maybe you can agree that on line 14, I print out that a is 5, b is 10, and c is 100. On line 16, I start a loop, and it says, is a less than b? And we notice at first the answer will be yes, because a starts at 5. In fact, why don't we just trace right through this? So here's my scoping diagram. I've got my box for main, and then I create three variables, a, b, and c. And this is lines 11, 12, and 13. 5, 10, 100. On line 14, I print out 5, 10, and 100. On line 16, I ask the question, is a less than b? And I look at a, and it's 5, b is 10, so yes, a is less than b. On line 17, I then set b to negative 10. Okay, so b is now negative 10, and I set c to 9999. And think about it this way. When I say c equals 9999, that's an assignment statement. The compiler says, okay, do the right-hand side. Okay, 9999, fair enough. Now go and put it in this thing. And just to be clear, the compiler has to actively find c. It goes looking on your diagram. It says, where is c? Okay, that's not c, that's not c. Oh, there it is. It's this thing. That's over here, c. I actually also should add my types. And so it finds it. And what I'm talking about with this subject of scope that I'm getting into is actually the process of how the compiler finds a variable. When I use the name c, how does it go and find that variable c? So it sets c to 9999 and then prints out a, b, and c again. So it'll print out 5, negative 10, 9999. I go back around. On line 16, I ask the question, is a less than b? And the answer is no, because a is 5 and b is negative 10. And I get down here and it prints out a equals 5, b equals negative 10, c equals 9999. So we'll try running that. And we'll clear. And it pretty much does what I predicted. Okay, so this is code, and it even says in the comment at the top, that works as expected. It doesn't do anything exciting. It's just pretty much a vanilla loop tracing exercise. Okay, so let's pivot. Let's talk about some code that doesn't work at all. So here's some code that has a syntax error. And I'll just show you the syntax error. It's not going to be that exciting. Maybe we already foreshadowed it earlier. It's going to say, oh, redefinition of b. So what's happening here is that, let's make up our diagram. So on line number 11 and 12 and 13, just as before, I make three variables. And they're all of type int. And a is 5, b is 10, and c is 100. And there's names a, b, and c. On line 15, I do something weird. I say create a variable called b. And the compiler has a problem now. Line 15 is a declaration. It says emphatically, create a new variable called b. When I say int b, I'm saying give me a new variable. And the compiler goes and looks and says, wait a minute, you already have a variable called b. If I make you a new one, I mean, okay, conceptually, if I go and make a new variable called b here, and I put the value 6 in it, if you ever ask me for b again, which one do you mean? How will you ever differentiate? That doesn't make any sense. I can't go make a new variable called b because the name is taken. And so it gives you the error. It says redefinition. That's an error because you can only create a variable once. You cannot have two variables called b in the same diagram because when the compiler goes and looks for b, it won't know which one to choose. Okay, so you can't redefine a variable. And the converse of this, of course, is that you can't create a variable twice, but you also can't create it 0 times. So if I move the declaration of A down here, then or the declaration of B, if I try and use B on line 16, it's going to say, I don't know what B is. I've never heard of B before because you haven't created it yet. But let's just take a look at that. It's going to be calling that undeclared. It says B is an undeclared identifier. So there it is. B is undeclared, and then that's the thing it's complaining about, my attempt to use B before I created it. So we can see, of course, we have to create a variable before we use it. We can't attempt to make two variables with the same name because that would confuse the compiler. Okay, so let's pivot again. Here is some code that does work, and it does something incredibly unsettling, for lack of a better term. I just told you, once you've created the variable b, you are not allowed to make another variable called b. And so I create a variable, we'll draw our diagram. So there's main, and then there are my three familiar variables, a, b, and c. And a is 5, b is 10, c is 100. Okay, so then I print them all out. I print out a equals 5, b equals 10, c equals 100. So I print out a, b, and c. I ask the question, is a less than b? The answer is yes. And so I enter the loop. I set b to be equal to -10, and then I create a variable c. And then it prints something out. And then I get down here and I print out the value of a, b, and c at the end. And I just told you that you are not allowed to create two variables with the same name in the same scope. And for some reason, this works. And I'll prove it to you. Before I run it, let's compile this code. So it's called scope 3. And it compiles just fine. And what's worrying about this is if you try running the code, it does something really, really weird. So it does create a new variable called c. It sets its value to 9999. There I am inside the loop. C has the value 9999, and B has the value -10, like I expect. Then the loop ends. And then on line 22, the variable C still exists, but has the value 100 again. For some reason, its value got reverted to its original. And that's scary, because everything I said a minute ago about how a variable can only exist once seems to be contradicted by this. And so I want to jump back and forth between examples. What's really happening is this concept called scope, which defines when a variable begins to exist, when it ceases to exist, but also at each step, if I ask you the question, what is the value of the variable c? It dictates, the concept of scope dictates where you get that value. And that means that we need a bit more of an advanced way of drawing our diagram. And so I'm going to rewind and talk again about this example. Let's trace through this entire thing and let's do it properly. Let's draw a proper scoping diagram. And here's how we do that. We begin at the beginning of main as usual. We draw ourselves a nice big box and we label it main. When you see a box labeled in the upper corner, at least using my notation, as I've said, the notation I use here is apparently unique to this course. That's just notation that I like using for my own purposes. You're welcome to draw whatever diagram you want. You don't have to draw my diagram. You have to get the right answer to questions. You're never asked to draw the same diagram as me, but I find it's a good technique. When I draw a diagram and I put an underlined name at the top left, I'm calling this big box a scope called main. The name I give to the scope is sort of for my own purposes. There are cases where you might want to name something differently, but I think main, it's obvious what that means here. It's the curly brackets that go with the unit of code that's labeled main. Now, we'll see next week what this actually means. It's called a function. And every time you see an opening curly bracket in your code, you are starting a new scope. And that means that you need to draw a new box inside of wherever you're already drawing things with that label. So I've already drawn a box called main. On line 10, like I've done in the past, I will create my variable n, and I'll give it the value 1. On line 11, I create the variable sum, and I give it the value 0, and it's also an int. And then on line 13, I ask the question, is n less than or equal to 5? And the answer, of course, if I look at the value of n, is yes. And that means I have to execute the loop body. To execute the loop body, I have to go inside curly brackets. Every time you see an opening curly bracket, you go over to your diagram and you draw a box inside of wherever you are currently. So right now we're inside of main. I'm going to draw a brand new big box, and I'm going to give it a label. It is a scope. Every time I see an opening curly bracket, it is a new scope. I'm going to call this scope while, because in my mind it corresponds to the while loop on line 13. You could also, for your own purposes, in brackets say, okay, line 13. Who cares what you call it? Just make it obvious to yourself what you mean. Okay, so right now I'm inside of this nested scope. And if there were curly brackets inside of this somewhere, I would draw another box inside of this box. Okay, on line 15, I ask, create a new variable called n squared. Whenever I make a new variable, I make it inside of whatever scope I'm currently in. So here, I'm inside of the while scope, and it's an int. Set n squared to be n times n. Okay, so this brings us to the second point. At any point in your program, you're always inside of some scope. On line 15, I'm inside of this scope. I'm inside of this box called while. When you're inside a scope and I ask you for the value of a variable, you always follow this procedure. So I'm inside the current scope and I say, what is the value of n? Here's what I do. I go looking inside my current scope for a variable called n. Do I see anything in this box whose name is just n? No, I don't. If I don't find what I'm looking for in this box, I go looking outside the box. Okay, so is there something out here called n? And the answer is yes, it's this thing. Okay, so that's the value I get. That means that n is 1. So I do 1 times 1. And that's 1, so I set n squared to be that. Okay, and now I say sum equals sum plus n squared. I'll just erase this. Okay, so what's the right-hand side? Well, my variable n squared. Okay, so I go looking in my current scope for a variable called n squared. There it is. Its value is 1. And then I go looking for a variable called sum. Okay, nothing in here, so I leave the box. And once you have left a scoping box in your search, you're never allowed to go back in the same search. So if I'm looking for the variable sum and it's not in here, I can leave a box, but I can't go into one. So I leave the box, I'm in this box out here, I say, is there a variable called sum? Yes, there is. Its value is 0. So sum equals 0 plus 1. Okay, so I take 0 plus 1, of course, that's just equal to 1, and then I assign it to this thing. And just like before, I go looking. Where is there a variable called sum? Okay, there's nothing in here called sum. I must mean this thing out here. So I set this thing to be 1. And then I clean up after myself. And the same thing happens on line 18. I'm currently in this scope. Go find me a variable called n. Nothing in here. Leave the scope and take a look outside. Okay, there's n. 1. So I take n, I add 1 to it, so 1 plus 1 is 2, and then I change n to be, I erase n, and then I change it to be 2. So what we have here are a set of rules that tell us not only where do we put a variable when we define it, but also how do we look for a variable if I use a name. And suppose I were to use a variable name that didn't exist. Here's what would happen. Suppose I wrote a piece of code like n equals y. Now, there isn't a variable called y. If you try compiling this, you will get an error. But what happens in the compiler when it sees this, n equals y? Well, it tries to do the right-hand side. It says, go find me a variable called y. So I go looking in my current scope. Is there a variable called y? No. So I leave it. Is there a variable called y out here? No. So what do I do? Well, I'm in a scope. It's the scope for main. If I can't find a variable in my current scope, what do? I leave it. Okay, I couldn't find a variable in here, I left it. I couldn't find a variable in here, I left it. So now I'm out here. So there's this weird, spooky wilderness outside of all scopes. Outside of main, there's just weird sort of amorphous nothingness. And I ask, is there a variable called y out there? No, still no. Okay, so there was no variable called y. That means that there's an error. I went looking for a name y, I couldn't find it, and so there is no variable. The compiler would give me an error. Now we'll talk in a minute about now you all were listening and thinking, wait a minute, what's that spooky wilderness thing about? We'll talk about that later. It's important, but only for completeness. For now, as you've seen, all of our variables that we define tend to show up inside of main or inside of a scope that's itself inside of main. So we're at line 18. We've updated n, we've updated sum, and then we get to this. And this is a key point, and you will need this on the final exam as much as you need it now. This is very significant. If you don't pick up on this early, it'll be really tough later in this course. Whenever you see a closing curly bracket, you are, of course, as of line 18, we are inside this scope here. When you see a closing curly bracket, you take your current scope, and I am not kidding about this. You take your current scope, that's everything inside this box, and you absolutely destroy it. Okay, so it's not there anymore. Because if you ever keep that on your diagram, you might get confused and use that data. As soon as I hit the closing curly bracket of a scope, the scope and everything inside it is destroyed forever. And I might just erase it. I guess I have an eraser. So I'll do that. It's gone. Some people just sort of, haphazardly cross it out. But if you accidentally see inside that box and look at a number that was in there, you might use it by accident. But the compiler won't. When the compiler hits that curly bracket, that while loop is gone. Okay, so I go back up and I ask the question again. Is n less than or equal to 5? And the answer is still yes, n is 2. Okay, which means I hit that, I have to do the loop body, and so I create a new scope. And when I said definitely you have to make sure you erase it a minute ago, I was thinking about this situation. You might know that the loop is going around again. And that means that you might just leave that box there. Don't do it. Whenever you hit that closing curly bracket, you destroy that entire box. Okay, so line number 15. Create a new variable in my current scope called n squared. And it's an int, and it gets the value n times n, which is 4 here. Okay, now set sum equals sum plus n squared. So, okay, n squared is 4. Sum is this thing out here. So this thing equals 1 plus 4 is 5. So that's 1, that's 4. 1 plus 4 is 5. Store that into sum. All right, and then n equals n plus 1. So in my current scope, there isn't anything called n, so I go outside. Okay, there's the n I'm working with. N equals n plus 1 means that this gets the value 3. And then I hit that closing curly bracket again, which means I just completely destroy the scope I was just in. It is gone, and it is gone forever. I might make a new scope in a minute, but it will not be this one. This scope is absolutely permanently destroyed. And I've mentioned before that the reason we like this kind of diagram is that it lets us see everything the compiler sees and literally nothing else. If we try and do things in our head, our brain will make assumptions and jump to conclusions, and that might mean that what we end up with disagrees with what the computer actually did. Okay, so I go around again, and I ask, is n less than or equal to 5? The answer is still yes, and so I create a new scope. It's called while. I then create a variable called n squared, and it's an int, and it gets the value 3 times 3 is 9, and then I add n squared to sum. So I say, okay, well, sum was 5. 5 plus 9 is 14. N equals n plus 1. This is the n I'm working with. It gets the value 4. I get this closing curly bracket, and I obliterate that scope. It's gone. I'm not really erasing I need to learn how to erase more efficiently. Okay, so then I go back up. I ask the question, is n less than or equal to 5? And the answer is definitely yes. And so I go through the entire process again. And then I say, okay, so I create a variable called n squared. What is n times n? It is 16. I then take so my current sum is 14. N squared is 16. I add them together and I get 30. Draw a better looking 3 there. And then I say n equals n plus 1. So now n is equal to 5. And then I get to my closing curly bracket, and you know the drill by now. It's all gone, and it's gone forever. And you're noticing me doing this, painstakingly tracing through this code, redrawing the box at each step. And you're thinking, that's a waste of time, Bill. I'll just leave the box up there. You go right ahead and try. But if you ever get confused and recycle values that were supposed to be in that box from one iteration to the next, all that time spent erasing will suddenly be worth it. So I get back up, I ask the question, is n less than or equal to 5? And the answer is yes for the very last time. So I say, here's my box. For my scope, I create a new variable called n squared. And it's an int, and it's equal to 5 times 5, that's 25. And then sum equals sum plus n squared. Well, my current sum is 30, and n squared is 25. I add those together, and I get 55. And then n equals n plus 1. That means that as of now, n is equal to 6. I'll just clean this up. I get to my closing curly bracket, and this box is gone. It is all gone. There is none of it remaining. It has ceased to be. It is pining for the fjords. If I leave it there, I might make a mistake. And there are exam questions where it is designed. The question is designed to see if you have properly erased the box. We don't need you to show us your diagram. We just care if you can give us the correct output for the code. But we can design questions where it's pretty clear if you're tracing properly. So I go back up and I ask the question again, is n less than or equal to 5? And the answer this time is no. So I go down to the end of the loop. And then on line 22, I say n squared is, and I go looking for n squared. And there is no variable called n squared. And that is why when you try to compile this code, I'll just scroll up and find my compile command from earlier. When you try to compile this code, it says on line 22, n squared is undeclared. There is no variable called n squared because as of line 22, there isn't. It's gone. Maybe there was a variable called n squared, but not anymore. And that's why that is a compile error. If I comment this out, it's all good because if it asks for a variable called sum, I'm in the scope of main. I get the variable called sum, and its value is 55. And we'll just try that out to prove my point. Whoops, I actually have to save the file first. You've all probably fallen into this trap yourselves by now where you forget to save the file. So this is called squares tracing. And there it is, the sum is 55. So using this scoping diagram lets us duplicate the sort of odd logic that dictates the lifespan of a variable. A variable is created at the line where we declare it, and it ceases to exist. It is destroyed forever when we reach the closing curly bracket of the scope that I created it in. Now let's jump back over to this example from earlier. So scope 3. So we saw that this code does compile, and for some reason, I am allowed to create a variable c twice. I'm going to delete this comment to clear up some space for a diagram. Let's trace through this. So the output is really counterintuitive. The example I've created here is designed to throw you off if you try and do the whole thing in your head, because it does look a bit ridiculous that at the end, c apparently is equal to 100, even though as far as I can tell, I changed it in the middle of the program. And you might say, well, maybe all the changes you do in the loop don't carry forward, but I changed b, and the change is still present at the end. So clearly, if I modify something in a loop, it does carry forward. And this is one reason why just skimming it over or trying to do it in your head can be very error prone. If you do it with a diagram, the diagram does all the work for you. And let's prove that. So let's trace this code. And actually, I'm going to generate the output as I go down here. Okay, so I start by creating a big box for main. There it is in my scoping diagram. And then I create 3 variables, A, B. After all this, after half an hour of drawing boxes, I've gotten pretty sloppy here. I'm going to tidy that up a bit. I should do better. I should have higher standards. I've already complained in a previous video that it's really the standards of the screen drawing software. I'm a narcissist, so I'll just claim it's not my fault. There you go, 5, 10, and 100. And my first bit of output, there's the output, is start. A equals 5, B equals 10, C equals 100. And then I get to line 16. I ask the question, is A less than B? And the answer is yes, 5 is less than 10. And so I hit that opening curly bracket, which means I create a new scope inside of main. And we'll just call it while. Okay. Line number 17, b equals negative 10. So I'm inside this scope, and I go looking for a variable called b. Do I find something called b in here? No. So I leave the box. Is there something called b out here? Yes, there is. As I go looking, I'm allowed to leave scopes to find the variable, but I'm never allowed to go into scopes. I can only leave the one I'm in. So I can't find b in here. I exit. I find b out here. I set it to negative 10. Line 18, it says create a variable called c. Now in this case, there is a variable called c out here, but this is a blank slate. There isn't already a variable called c in the current scope, so it's not an error to create a variable called c as long as there are no other variables in the same context with that name. And in this case, there isn't a variable called c in this scope. There's a variable called c in the outside scope, but not in this one. So I create a variable called c and I set it to 9999. Then on line 19, I print some output, in. And I print out the value of a, so I go looking for a. Okay, nothing called a in here. Here's something called a, 5. I print out the value of b. Nothing called b in here. Here's something called b, -10. I print out the value of c. Anything called c in here? Yes, it's this. So I print out the value of c is 9999. And the issue here is that, yes, there's another variable called c, but the compiler has a very methodical process for searching. It starts in the current scope and works its way out. As soon as it finds something, it is done. And so it found this thing first, it prints out this value of c. Then on line 20, I hit that closing curly bracket, and you know what to do. We destroy the entire scope. It's gone forever. If I leave this box up or I just sort of scribble it, I might accidentally look at this value of c again. I don't want that. I want it gone. So I get rid of it. Completely obliterate it. Maybe I do a better job than last time. I get rid of all these little bits and pieces lying all over the place. I swear, this is so much better on a chalkboard. There's just something satisfying about erasing a chalkboard. Okay, so there it is. And then I get to line 22 and I print some more output. End. A equals 5. B equals -10. C equals 100. And I'll maybe call your attention to the fact that on line 22, there is no confusion whatsoever in my mind about values of a, b, and c. It's obvious. The diagram has them. They're right here. I don't need to look for anything else. There's no confusion about two different variables called c. On line 22, there is only one choice. Because I kept my diagram up to date, I don't need to worry about all the other weird values from the past getting in my way or whatever this is causing me trouble. If I draw the right kind of diagram, the diagram sort of does the work for me. And so this idea that I can create variables inside of scopes, and the variables in some cases can have the same names as variables on the outside, as well as the fact that we now know that variables have a finite lifespan. They're created when I declare them, and they cease to exist when I hit that curly bracket at the end of the scope. That's significant because the next topic we're going to discuss, which is called functions, and covers how to package up bits of code into reusable appliances so we can use them over and over again, that relies heavily on this notion of scope, because there might be lots of different units inside my program that each have variables called a, b, and c, but they're all separate because they're all kept inside of different scopes.